All right. Welcome. We're back here with section 5.2. We're going to jump into a little bit more algebra. Today we're going to be talking about simplifying algebraic expressions. And so I've got these notes here, and I just wanted to walk through them really quickly. Whoops, there we go. So a couple of things that are important to know: that a lot of times in math, terminology is very, very specific. The way that we specifically define certain words, they all mean something very, very specific. And so there's two words here that I want to talk about really quick. The first is the word solve, okay? So when you see the word solve appearing, you're looking for a variable to equal a number. Remember, a variable is just a letter, okay, that can represent an unknown quantity. So when we're solving it, we're looking for a solution, okay? When we're looking for a simplification, or we're using the word simplify, it just means we need to break it down into its most simple form. And so this is generally the biggest mistake a lot of people make, is that they'll say, the question will ask you to simplify something, but then what they'll do is they'll go and they'll try to solve. And in reality, you can't solve anything if you're just trying to simplify it. The reverse is also true. You can't solve or you can't simplify something if you are, well, I guess it's kind of true, but you can simplify something, but you have to, if you're solving it, you need to find a value for your variable. So your variable is going to equal a specific number or quantity, okay? So that's something to specifically mention and address, okay? So in general, what we're going to be doing in this section is just removing or distributing parentheses. So in many cases, we'll have parentheses that are being, there's a certain sign that is applying to the parentheses, and it's affecting every single thing that happens inside of that parentheses. So if you see this example here, I've got 3x minus this whole thing. And what's happening here is that minus sign is affecting the 2x right there. It's also affecting the minus 4y. And so you have to be really cautious to make sure that you're applying that minus sign to every single piece that's inside of that bracket. So effectively what we have is the minus is going to distribute itself to the 2x. This is using the distributive property that we talked about last time. 3x is going to stay just as it is. The minus is applying to the 2x, so we have a minus 2x. And the minus is also applying to the 4y. So the 4y turns into a positive, because if I negate something that's negative, it makes it positive. You've probably heard somebody say like, oh, I can't not eat ice cream. I mean, I hear that from my kids all the time. I can't not eat ice cream. So what does that mean? It means I have to do something, right? It's a double negative, so it undoes itself and turns it into a positive. Okay? All right. Another terminology thing that we are going to be talking about is the word term. I know that sounds really kind of terminology and term. It's all tied together. But a term is a single number or a product of a number and one or more letters raised to powers. So I have a few examples here: 5x, 8x squared, 24y, 15, 2a squared b to the fifth, and say, for example, like a t. If I took that same kind of, I guess if I was trying to define the terms that are listed up here, in this expression, I would have 3x, that's a term, minus 2x, that's also a term, plus 4y. The 4y itself is also a term, okay? So there's three terms in this particular expression that we're dealing with, okay? The word coefficient is a number that kind of sits in front of a variable. So if you have a number sitting in front of a letter here, so 5, that's the coefficient. 8 is the coefficient here. 24. We'll talk about that one here in a minute because it's kind of a unique situation. It's not really a coefficient. The 2 here is a coefficient. And then on this t, really quick, you'll notice that there isn't a coefficient in front of it. If there's no coefficient listed in front of a variable like this, And then the coefficient is implied to be a 1. Okay, so you can kind of think of like an imaginary 1 sitting right there, and that would be the coefficient in this case. So for the 15, this is not a coefficient, and there's no variable attached to it. So what do we call it? I don't actually have it listed here, but the 15 is what we call a constant. A constant. This is a constant term. These are all variable terms except for the 15, which is what we call a constant term. Okay? All right, so when we combine things together, our goal is to combine what we call like terms. They have to be alike in their composition, the way that they're made up. Okay? So if, for the most part, the way that you can identify like terms is by comparing the variables and the exponents together, and they have to be exactly identical. The coefficients make no difference. The numbers in front make no difference. It entirely comes down to, are the variables and the exponents attached to them the same between the two different terms? So for example, here's kind of a nice little breakdown of things that are like terms and things that are unlike terms. So for example, 2x and 3x. Do you notice how the x's are exactly the same? They actually have the exact same exponent. In this case, it's just a 1. It's an implied 1. So because the exponents are the same, the variables are also the same, you can actually combine these together because of the like terms. Unlike terms, well, let me go through all the like terms here. I've got the ax as the next one for the b one. AX and AX, again, it's exactly the same. It's like playing a match game. X cubed and X cubed, so the exponents and the variables that they're attached to are exactly the same. A squared x to the fourth, A squared x to the fourth, A squared x to the fourth. I do not care about the numbers that are out in front. It makes no difference, the numbers in front. The only thing that matters is the variables and the exponents when it comes to like terms. For unlike terms, you can kind of see the distinction here, right? Here, do you notice how the variables and the exponents are different? So while this shares the same variable, because they have different exponents, they're not like terms. So we cannot use them. AX and BX are not the same. They have to be completely identical, so they have different variables. X cubed, X squared. Again, same variables, but different exponents, so they're not the same, not like terms. A squared x to the fourth, AX to the fourth, A squared x to the third. While they may have the same variables, they all have different exponents. So again, when you're comparing like terms, they have to be completely identical in terms of their composition of those variables. Okay. Let's go ahead and jump into the notes here. Let's actually go ahead and do some examples. So we'll switch it over here. There we go. All right, so real quick, let me go ahead and close this out, speed my computer up. So some of the questions that we have to do, number one, are going to be involving a removing of the parentheses. I always spelled this wrong, with an E. Parentheses. Remove the parentheses, okay? So this is question number 3 out of the back of the book, or not the back, I guess it's the back of the section. So here we've got A minus B minus C. I think there's a minus in front of the B there as well. Yeah, let's do that, okay? So as a quick reminder, we have to distribute this minus sign to both of the pieces that are attached there, okay? And so what's going to happen is the minus applies to the minus to turn it into a plus. And then the minus applies to the minus C to make it a plus C. And that's our answer. Boom. All right, let's do another one. So we've got A minus B plus C. Same idea, we can distribute to both pieces. And we're going to have a minus is going to be a plus, minus a plus is going to be a minus. So you can count the number of minus signs to figure out if it's plus or minus. In this case, a minus and a minus is a plus, a minus and a plus. Since it's an odd number, it's going to be a negative. So there we go. All right, let's do another one. 12. So this one's a little different because we have to not only, we have to just, I guess, apply the parentheses. I don't think we're combining like terms yet. Well, let's just take a look. X, that's a number with no X. That's a Y, that's an R. There's no like terms, so we can't combine them. But what we can do here is apply that negative to both the 3Y and the 4R, and then we'll have our parentheses gone. So the first piece we don't actually have to do anything with. We can just rewrite it because there's nothing in front of it that's being applied. And so as a result, we can just rewrite it. The bottom one here on the right-hand side, we have to apply that minus. And you can draw these little arrows if you want. I'm only doing it on the first couple here, but I'm probably not going to after, the next few minutes. I just want to illustrate exactly what I'm doing in every single piece. So that's going to be my final answer. This is our fully simplified form. That's that word simplify again. All right, let's take a look at the next question, question 16. Minus 9x plus 6 minus 3z plus 3w plus 1. Now here, we have this minus sign that's being applied to 1, 2, 3 different pieces. And it does look like there is a like term. And I'm going to underline it here in red. It's red. It's blue on your screen. That right there and that right there will be like terms, okay? Technically, because they're both constants. If you just have two numbers together, you can add them and subtract them. You don't need to worry about the variables. You do the thing that you've been doing ever since you were a little child. So minus 9x plus 6. Now we apply that minus sign to every single piece. Minus 3w minus 1. And now as a result, you can see how we removed the parentheses, but we still have the 6 and the minus 1 there. So as a result, what I'm going to do is I'm going to write the variables first, 3z minus 3w, and you can combine the plus 6 and the minus 1. 6 minus 1 is just going to be a plus 5. And that right there is going to be my final answer. Okay. Now the next part of this, I guess, is really to combine our like terms. So we were distributing that minus sign in many cases. If there's no minus in front and it's just a plus, then you can just remove the parentheses, just in case you're wondering. I think I had minuses in front of every single example, but let me actually do another one really quick. This isn't any particular number. Let's just take the minus 9x plus 6, and I add it to 3z plus 3w minus 1. Okay. What was the previous question? Oh, I had a plus 1. Whatever. So in this case, this is the same thing as a minus 9x plus 6x. Because it's a plus sign, I can just remove the parentheses. I don't have to worry about distributing anything because it's just a plus. So in this case, it's just 3z plus 3w minus 1. And then you can go ahead and combine all your like terms. In this case, oh, this is not a 6x. My bad. Right there. There we go. I got a little happy, a little excited. So this is going to be a minus 9x plus 3z plus 3w. And then 6 minus 1 is going to be a plus 5. Okay. So that would be how you go about this process with a plus sign. All right, so on this next one, this next series of questions, we're going to combine our like terms. And the goal here is to try to match everything up as best as we can, all the variables, all the exponents. And then all we do is we just add the coefficients together. So this is question 23. For example, if I've got x squared plus 2x squared plus 3x plus 7x, do you notice really quick how these guys are like terms and then also these guys are like terms? I can't mix and match the x squareds and the x's because they're completely separate and different. However, I can combine the things that are just x squareds with each other and the things that are x's also with each other. So if you remember, we talked about this, but if there's no number in front of a variable, you can just assume it's a 1. Okay? So I put that there, but I'm going to remove it because it's just good to kind of build that habit of recognizing that right off the bat. So this is a 1 plus 2 is equal to a 3, and then all I'm going to do is just bring the like term along for the ride. And then for the second piece, I do exactly the same thing. These are the two like terms, but I can just add the 3 and the 7 together, and I'm going to get a 10. And that right there is going to be my final answer in terms of simplifying, okay, or combining the like terms. Let me go ahead and do another one. So 26, I've got 4x plus 6x minus 5x, okay? Now, one thing you'll notice is that these are all the same. They all are x's. They all share exactly the same exponents. There's no difference between them at all. And so now one of the things that we can do, we just add the coefficients. So 4 plus 6 is 10. 10 minus 5 is going to be a 5. And the variable comes along for the ride. All right, let's go ahead and do another one. This is our final answer. So now let's do question 27. Suppose I've got 3a plus 5b minus 2a plus 7b. So you're probably noticing really quick that the order really doesn't have to matter with the problems that they give you. As long as you just combine the like terms, that's really all that really makes a difference here. So 3 minus 2 is what? 1. So because the 1, remember, the 1 is implied, if I don't write anything in front of the variable, I'm not going to do that. I'm just going to write the a. So there's an automatic 1 that's just implied to be there. And now what I can do is I can take the 5, add it to the 7, and I'm going to get a plus 12b. Just bring the b's along. All right, so 32. This next question, 13x squared plus 14xy plus 6y squared minus 3y squared plus x squared. Okay, so there's a lot going on here. But again, if you just remember, everything needs to match up perfectly. All the variables need to match up perfectly. So real quick, you'll notice that there's an x squared and an x squared, and I don't have anything with the xy, so I'm just going to leave it blank for now. And then I've got the y squareds right there. So 13 plus 1, this is going to equal 14x squared. I'm just going to leave the 14xy there because I can't do anything with it. It's just kind of is what it is at this point. And then the last one is to take the 6 minus the 3, and I'm just going to have a plus 3y squared as a result. Okay. All right, one last one, 44. Suppose I've got 5x minus 2x. Oop, see, I made a mistake here. 2 plus 3x. Okay. So what I'm going to do here is, first off, I'm going to distribute the minus sign just like we did before. And again, I'm not going to write the arrows, but you have to just recognize that this is going to be listed as that. And now I can go ahead and combine my like terms. I've got the x's listed right there. So this is going to be 5 minus 3 is going to be a 2x, and I'm going to subtract a 2 directly from that. Okay? And that's it. That's all we have for section 5.2. So if you have any questions, feel free to let me know. But otherwise, I will be seeing you next time. Hope you have a good one.